Welcome to the Joy of Coding!
Hello, and welcome to episode 213 of The Joy of Coding. My name's Mike Conley. So good to see you. Hopefully that volume wasn't too loud. I did notice that the input capture was like spiking. I apologize if the gain's up too high. Maybe I'll just back that off just a little bit. Hello, good to see you. It's episode 213. I'm gonna be hacking on some Firefox stuff today. It's so good to see you. Let's get started. 1 second while I switch cameras. Alright, so here's today's agenda. Like I said, it's episode 213, April 22nd, 2020. A reminder, no plan survives breakfast. I don't know what's going to happen today. I don't know whether I'm out of coffee for the most part. I didn't even plan that. I've got too many mugs surrounding me. I have to clean up my desk. There's just too much. There are too many mugs. And no plan survives breakfast. Things could go horribly wrong. I might get stuck. I might, come up with solutions to problems, or I might not. I might go down a blind alley. Who knows? This isn't like one of those streams where I've got like a pre-written solution kind of on my side where I'm like hacking something out that's already been solved. I'm going to be doing this live, so it's real software development in the raw where things can go wrong. And so I just wanted you to be aware of that in case you're wondering why I spend so much of my time looking at my screen and just kind of like thinking. Because that's often what someone needs to do in order to write software. One of my lessons I've learned over the years Wow, what just happened? Sorry about that. If you were... Hang on a second, I have to start recording too. I'm not sure how long I wasn't streaming for. I had just gone into this like deep dive on the episode guide and what it was for, but apparently OBS crashed in the background and I didn't even notice it. Sorry, everybody. Where was I? I don't know what to say. About 2 to 3 minutes was lost. That's the very beginning of the stream. I apologize. So I'll skip talking about the episode guide. Just know that it's there, and if you're ever interested in seeing more context about the episodes, just check it out. There's a link in the agenda, and you can also send your own pull requests to the episode guide. So what do I want to do today? Well, today I'm going to be kind of going deeper into a problem we were looking at last week, which was about scroll position and about new tab. I have further information. About that bug. So this is the bug that we were looking at last week. It's fairly easy to reproduce. I'm at the new tab page here. Let's suppose I scroll down and I see an interesting pocket story. I click on that pocket story, I read the story, and then I click back. Now, if you'll notice, after clicking back, I'm back up at the top. I'm back up at the top of the page, which is not ideal. Ideally, I'd be back where I was, especially if I want to go maybe to the next story. I don't want to like have to re-scroll back down. The browser is supposed to remember the state I was in, like what scroll position I was at, even whenever I'm transitioning between pages. And the About New, this is only on Nightly right now, and the reason that About Home or About New tab is special is because currently it runs in its own, it's run in its own content process. So it's got a special content process, and then when we navigate like to the story or this story or whatever, we do what's called a process flip. We transition to a different content process. And then when you click back, we process flip again to go back to the special content process that exists for About Home and About New tab. And that's relatively new. That's something that's only enabled on Nightly right now. And that process flip is what's causing us to lose this information. So if you're, for example, on beta or release or dev edition right now, you probably don't have this bug, but you will unless we fix it, because the special content process is currently enabled on Nightly and it's set to ride the trains in a couple of weeks. So I'm gonna hopefully try and get this fixed before we uplift. Wow, there's a lot of chat in Twitch about. I apologize about OBS crashing. I'm sorry I didn't notice. I should probably have had a closer eye on that. I apologize. What else is going on? The stream's back. I lost about 2-3 minutes. 4 MSL panicked. Sorry for making you panic. And then before the agenda. Okay, so we lost a lot of information. Is it possible with infinite scroll? Okris asks. I don't know. If you're asking about the new tab page, I guess one could create an infinite scroll if there were enough pocket stories, and currently it's not set up. Like About Home and About New tab is not set up for infinite scroll. That's not a setting that's built in. But certainly, so I myself am actually quite a fan of Pocket. I enjoy these stories. I think they're high quality. I found very interesting things. So I myself would find it interesting to just kind of scroll through infinite scroll stories if I was looking for something to do, like if I wasn't already on my way somewhere. Okay, so what have I found out since last week? Well, 2 pieces of information. The first piece of information is that we persist persist scroll position in a couple of different ways and in a couple of different places. So let's look at an example. Suppose I go to mozilla.org. And suppose I scroll down and I click on this link, and now I click back. Notice I am still at the same position I was in before. This is the ideal scenario. I clicked forward, I'm here, I click back, whoops, I click back, and I'm here. Now if I, and it works as well if I click forward. Like, this is where we want to be, going back and forward. That scroll position, and the reason that's working is because we're not process flipping. And that scroll position information is held in a couple of different places. The session history entry is where I believe we currently store that information in a special structure. And then whenever you, and then on top of that, there's also something called the BF cache, which actually just saves everything, the presentation of a page, in memory, so that it's much easier to go back and forth between like pages in your history. We have this BF cache thing. And so we don't even need to persist the scroll position information in that case, even though I think we do anyways, but what's being restored is actually just the full presentation layer, and that includes scroll position. So we have BF cache, which has a limited number of entries. Like, I think there's a maximum that's in about preferences or about config or something, and once we've reached that cap, we rely on using the scroll position in session history to both reload the page from like the network cache and then recompute the display and then change your scroll position. And then finally, the last place I'm aware of where we persist scroll position is in session store. So session store remembers what happened, what your session state is in, so that whenever you restart the browser, we can like bring it back to life and restore your session. That's what its job is to do. And for each tab, whatever currently active page is in each tab, we persist the scroll position for that tab. So that means that if I had had a new tab, like I think this is true, let me actually test this, is that if I restart, well, you know what, I don't think this is going to work out, because about new tab is the sort of tab that we don't persist normally to session store. So for example, if I turn on automatic session restoration, I have a feeling that if I open like a bunch of new tabs up and close and restart, it's not going to bring them all back because new tabs are exempt. Oh no, it does. Okay, so if it does, I want to see if it remembers my scroll position. So here I've scrolled down, I close, I restart. Okay, it does not. So that's interesting as well. And if I look inside of the browser toolbox, and I look at the session store get tab state G browser selected tab, and I JSON parse that because it comes back to us as a string, it does have scroll information like recorded in it. It does know that I'm at 0, 1, 2, 3, 2, but for some reason that isn't getting sort of reset or persisted. It's not getting used whenever I restore the tab, and that it's possible that the reason it's not being used is because this page is generated dynamically, and so the actual like scroll position or like the scroll height of the page when it actually loads, there's nowhere to scroll to. So maybe whenever we restore, there's nowhere to go to, and then when we dynamically load and the height of the page it increases, it's too late. That's my theory anyways. Anyway, so I've mostly been rambling, but what I want to look at is part of session store where we persist the session history entries as well in session store, and see why we don't persist the scroll position of the back and forward entries. Because session store, it looks like, I'm digging into the code here, looks like it was designed to do that, but it's not doing it, and I don't know why. So first lesson that I thought was kind of interesting is that there's actually a web API for this. If you go to MDN and look at scroll restoration, this is something that you, like if you're a web developer, this is something you have some power over. There's this API called history.scroll restoration, and if you say history.scroll restoration should be manual, then you're telling the web browser, hey, don't remember where the user has scrolled to if they go backwards and forwards. And auto is whenever we will remember. The browser will attempt to remember. And I believe auto is the default. Like if I just go to about blank, and then I look at, let me pull up the console and I go history.scroll restoration, auto is the default when we load any kind of page. So that's interesting. That's the first piece of information. And let me write that down actually in our notes. Here. So there is a scroll restoration API on the history window global that sites can use to opt out of site. of the browser remembering scroll position in like session persistence. So I think that's an interesting piece of information. We'll record that. I don't think that is what's like breaking us here. For example, I don't think it's about new tab or about home that's saying it's opting out of this or anything. But I bring this up because of a particular bug, or no, chunk of code. Where is it? It's in session. I think it's sessionhistory.jsm. So this is a module. Sessionhistory.jsm is a module that its job is to look at a doc shell. A doc shell is a thing that knows how to view, like, load URLs and has back and forward history. So it's basically like the atomic core, the kernel, you might even think of a browser element or like a frame. It's a thing that knows how to go backwards and forwards and knows how to load a URL. That's like the simplest definition of a web browser tab, for example. And that's what a doc shell is. And a session history knows how to collect information from a doc shell and serialize it into a form that can be persisted to disk and then restored. And I have a feeling this is falling over for us, or like, it's not falling over for us, but we can use this to fix the bug. Ultimately, I think the more appropriate bug fix is actually going to happen whenever the team working on a project called Fission finishes the work to transition all of the session state from the content process into the parent process. That's kind of like in flux right now, and I've been in touch with that team, and if we look at the conversation in the bug, you can see where that resulted in. Or no, sorry, it wasn't written down. I had a conversation with them over Matrix, sorry, and the resulting decision was that this will be fixed whenever the Fission team finishes moving session history state from the content process into the parent process, but in the meantime, I should find a workaround, because that fix, that session history work into the parent process, probably won't be for a couple of releases. So using the session store module might be a sufficient workaround for now, because session store is what's actually used whenever we do a process flip. So this is the mechanism that we'll rely on, and then eventually, whenever the Fission people transition us away from session history living in the child process to session history living in the parent process, we don't have to rely on session store so much. We can get rid of this workaround. We actually can probably make session store a lot simpler, because everything lives in the parent process, or all the most important stuff lives in the parent process. So what I was looking at today was some code that looks like it already tries to serialize the scroll position of the page. And that was here in serialize entry. Its job is to take a native session history entry that's like, if you've got, a back forward history, you were at About Home, and then you were at a Pocket Store, and then you went to Mozilla.org, and then you went to Facebook. Each of these places that you went to is called a session history entry, and that's what you can go back and forwards to with your back forward button. And this serialize entry function's job is to take one of those native session history entries and to turn it into an object that can be persisted to disk as JSON. And so there's a bunch of stuff in here that it like pulls out of the native object and encodes it into like a JavaScript object. And this part is really interesting. So this part is like, hey, are we supposed to be has the site opted in to using manual scroll restoration? Have they used that API? If true, skip this block and tell the entry that scroll restoration is manual. Now, I know this, having tested it, that this is false for the About New tab page. So we actually entered this branch. And what's interesting is that we're actually trying to get the scroll position of the page after we transitioned away. But the problem is that by the time we do this, the scroll position is 0. Like, even if we'd scroll down halfway, by the time we do this process flip and we like try and preserve the original page's scroll position, the scroll position has been reset to 0 for some reason, and I don't know why. And I think that's the mystery we're going to try and solve today. So that was a really, really long explanation for the context of what we're going to be looking at today. And I've got a couple ideas on tactics we can use to try and figure out why the scroll position is 0. And actually, now that I think about it, I'm going to sign into my virtual machine. Folks, I don't know how, like, what's the dealio? Why is OBS crashing so much? I have a feeling this recording is going to be absolute junk because of all the interruptions with OBS crashing. I apologize. I don't know why OBS is crashing. Am I, like, running out of memory or something? No, memory seems fine. Just OBS is being, like, really crashy. I'm gonna keep an eye on it. I don't know what to do. My bad. Oh man, I keep typing in the wrong password for my Linux box. Hold on. There we go. So I've got a RR running on my Linux machine. I've signed into the VPN, so I might use that as a tool to figure out why scroll position isn't being persisted. And I'm also going to be using, probably my own debugging, some printf debugging to try and figure some stuff out. 4msal goes, so far it's amazing. Okay, so I'm so glad to hear it. You're amazing. Thank you, 4msal. You're amazing. Okay, so why is the scroll position 0? That's what I want to know. Whenever we do this. And you know what? I've changed my mind. I think I definitely want to do this inside of RR. I don't want to, like, I apologize that we're going to be, like, spending most of our time inside GDB, but maybe that's interesting. Maybe that's what you want. I'm going to try and reproduce this bug in RR, and then I know that, like, we did this last week, maybe. I don't remember if we used RR, but I'm going to do some small instrumentation. The first thing I'm going to do is I'm going to go into Browser Component Session Store. I'm going to show you a trick. Show you a trick that we use. Session history. Where's session history? Where's session history? Where's session history? Where do we keep that? Session history module. It's under Toolkit. Oh, Toolkit module session store. Okay. So Vim Toolkit modules session store session history. What I'm gonna do? No, scroll. Oh, it's capital S. Is I'm going to put in a very rarely used function here, math.sign. This is a trick you may have seen me use before. This is a way of like normally if I was using the JavaScript debugger, I would use like a debugger statement to tell the debugger, hey, breakpoint here. If like I didn't have the ability to set the breakpoint in advance. You can do it programmatically. Well, with RR, it's more tricky. I mean, I guess there's a way you can tell the NSI Debug 2 user interface to like hit a breakpoint if a native debugger is attached, but this is the trick I've been using for years. And especially this is particularly useful in RR. Because what I can do is I can hook the math.sign function and then pretty much know exactly where I am, even though I'm in JavaScript. And this is a tool. This is a trick that I think BZ or some engineer, some prestigious engineer at Mozilla taught me a while back. So I'm going to build that, and then I'm going to reproduce the issue, and then we're going to record with RR. So let's record with RR right now. So how we do that? We say display 0 because we actually need to interact here. I'm going to say mock run debug debugger equals RR. And now I need to switch to my sign into the machine where the display is. Hang on a second. Okay, it did it again. It did it again. I have a feeling it's every time I start. It's every time I open a window or a dialogue comes up. Is this? I wonder if it's like. Is this a crash that? Hotfix. I wonder if I need to like apply some changes to OBS. You know what I'm gonna do? I'm gonna just sort of like. I'm just gonna go ahead and install an update for OBS like right now. So give me a second, because I got a feeling I need to apply this patch. 1 second. I just gotta download it first. In the meantime, yeah, you can sort of see what my plan is. I'm gonna be opening up. Oh, we crashed here. Why did we crash whenever I was running debug mode? Do I have like a different? Oh, I was debugging a different thing at the same time. Let me shelve HG update to central. Prune tip. HG unshelve, and then mock build. So I'm gonna do all those things in a row. Okay, I'm going to restart OBS. Just give me 1 second. I'm back. Hopefully you can hear me. Yeah, sorry for the super unstable stream today. I'm not I'm hoping that that's the end of OBS crashes for the day. We'll see. In the meantime, just to catch you up, I'm preparing my Linux box here to use RR to sort of capture us in a really interesting state for this bug. To try and figure out why the scroll positions are getting blanked out. And what's particularly interesting about this state, actually, here, maybe I'll do, just trying to think if there's anything else I can do to make this interesting. No. Never mind. I have to wait for this part of the build to finish. But while we're waiting for that, let's also look at some of the other stuff that's in the session history. Like, get scroll position is supposed to help. And if we are able to get the scroll position and they're not 0, and in our case they are, then it concatenates them together as a string value. It's like the x value, comma, y value in this entry.scroll property on the object. And then there's this layout history state, and I don't know what this is. And apparently we can serialize presentation states. And I want to know what that is. A serializable representation of a presentation state. This also, for example, this also has scroll information. So you know what I'd like to do, actually, is determine... It's almost like there's redundancy here. There's like different sorts of things that are being... different chunks of information that are being persisted with regards to scroll. And that doesn't super surprise me. I mean, this part of the browser is really old. Really, really old. I mean, like probably from the Netscape days. Not necessarily this code, but like the scroll position persistence stuff. And so it does not surprise me that there are like really, really weird edge cases in the engine, or like little bits of redundancy and confusingness here and there. As you hack on Firefox code, the older the code is, the more you find that that's the case. And that has less, I don't know if that, I'm not trying to judge the people who worked on that code. They were trying to solve the problems at the time. It's also that the state of the web was way different. You know, everyone was disagreeing on how the web was supposed to work. And there weren't like browsers communicating very well on how the web was supposed to work. Everyone was just kind of like inventing stuff. And then they would like have to adjust and evolve while also maintaining backwards compatibility. So a lot of the older stuff is like kind of a ball of mud. All right, I want to understand what's going on in here. So actually what I think I'm going to do before I run RR is I'm going to go back to our current window. Here, I'm going to open up the browser content toolbox. I'm going to add some log points to session history.jsm as states. I'm going to add a log point. I'm going to say x dot value, y dot value. So that's 1. And then here, I'm going to say I'm going to say layout history state. Oh. I'm going to log whether or not one exists. And then I'm going to say get serializable pres state. I think I want to log information there. Serializing pres state. And then add a log point here. I'm going to say pres state scroll X. I'm going to say pres state, or I'm just going to say pres state scroll, because it looks like it's the same model where it's like X comma Y inside of pres state.scroll. Okay, so we've got some log points here. Let's have this run in the foreground. This is a local build, so I'm not going to send these crash reports. And then let us see what happens. Pull up the console, and now let's scroll down, and I'm going to click on this baloney detection kit link. Okay, so it looks like the X and Y scroll positions were both 0, even though that's baloney. Like the Y position was definitely changed. We had scrolled down. There also appears to be like 2 runs of the function, so I want to know more about that. So maybe I'm also going to log the URI to make it easier to distinguish. Yeah, display spec. I'm gonna log the SH entry URI display spec. Serializing that. Okay, so let's go back. Let's clear this out. Click on hydration. So serializing about new tab. And then we say X and Y scroll positions are 0. And then also attempts to serialize this page that we're on, the pocket page. And then we're serializing about new tab again. And then also attempts to serialize this again. Why are we doing it twice each time? That's very strange. I don't know why we do it twice. That's a question for later. So, why are we serializing twice when transitioning from between processes? So that's a question for later. What I want to know is why are the scroll positions 0 each time? So what I'm going to do is I'm going to go back to my RR build here, and I've got my build. I'm ready to rock. I'm going to say display run on display 0. Mock run, debug mode, debugger is RR. Actually, I don't think I need -- debug. I just need this part. I'm trying to think if there's anything else I need to do. No. Okay, so let us do this. So now I need to switch to my Windows box here, where eventually my debug instance of Firefox is going to display here, and we're going to reproduce the issue. Then I'm going to shut down, and then we're going to load up the trace inside of RR. So because it's a debug build of Firefox, it's going to be a little bit slow coming to the surface. Like really slow. There it is. That's really slow. What's going on? Yeah, it's like not responding to user input events just yet. Well, I mean, like a debug build plus the fact that I've got RR attached doesn't help. This is particularly slow. Oh, here we go. Finally figuring it out. It's loading pages. Okra says, if really slow, we might see how Firefox renders the page. Maybe. If you're actually interested in that, there are neat visualizations of how, at least, Danny Colin asks, am I running an Ubuntu VM inside a Windows VM? No, I am not. This is I'm remote desktoping into my Windows machine at the Mozilla office, which has an Ubuntu VM running in it. So this Windows outer window that you're seeing is actually my this is like a real machine, and then the Ubuntu running inside of it is my virtual machine. Okay, so wow, it is taking us a while to do this stuff. Debug builds so slow. So slow. I got a feeling we're swapping a lot. I might be running out of space on this disk. All right, now I'm gonna scroll down. Like, look at all the hard drive activity. I got a feeling we're swapping like crazy. All right, I have scrolled. Now I'm going to click on this. Let me click. Thank you. Oh, and what was my content process? What was it? 427. Okay, good. I need that information. We'll want to remember 427. That was the process ID. Akris asks, is it also running inside RR? Yes, it is. It should be. The replay is being recorded. Or it should be. Yeah, we're saving execution trace. So now that we've transitioned That's probably enough information, but I am also going to go back to reproduce the issue, so I hit back. Wait for it to figure itself out. Thank you for writing 427 inside of the chat. That's a great way for me to remember. 427, that's our process ID. Not only is this a debug build, it's an unoptimized debug build. Running on a VM that's not very high powered with RR, and it's nearly out of hard drive space. No, it's nearly out of memory, so it's probably swapping like crazy. So there are a lot of factors here that are contributing to why this is so slow right now. And new tab page says it's done loading. I don't believe you. What's happening here? It's like, okay, finally we've become something that paints. Okay. So now I'm going to quit. I'm going to exit. So we captured the bug. That was really painful. So my apologies that you had to witness this. But now I quit the browser. Okay. And now we can put this away. We can go back to our nice console. Wait for it to shut down. Watch while it does its RR logging. No need to check the process ID now too? No, thankfully, the process ID will have remained the same in this case because we keep the privileged content process alive even whenever it's not being, even whenever you've browsed away from it. And that's because we preload the next About New tab in the background as a sort of a performance optimization. Okay, so here we go. Replay, and we're gonna say which process we want, 427. So the trace is being replayed, and we're going to automatically attach to process 427 whenever it is spawned. I'm gonna freestyle rap for you. Here we go. Yo. Time to use our tool. It's the best. It's really, really, really cool. Helps find bugs. Helps you find bugs. What do you say? Let's go in and find the bugs. It's like play, except that you're in a bash terminal. I don't know what rhymes with terminal. Let's keep going here. So I'm gonna break on our math.sign function. So I've added a breakpoint for a function that's not yet defined, but it will be, and then I continue. Terminal. What rhymes with terminal? Verminal? Worms in bowls? Ugh. Alright, well, phenomenal? Terminal, phenomenal? It's a bit of a stretch, but, you know, we can shove that square peg into the round hole. I've got myself a terminal. It is so phenomenal. There. Square peg, round hole, sledgehammer. It is an optimal terminal. Phenomenal. Okay, so we're running the trace now. This might take a couple of minutes. While we're looking at that, let us see what's going. Let's see if we can figure out what might clear out session history information. Let's also see where we would expect the session history information to be persisted. We had our build here and with our logging. If I were like to scroll down and then click on a link, well, what? No, not one that opens a new window. One that stays in the same window. Here. No, don't open a new tab. Oh, you know what? I need to attach to the right content process. Silly me. man. All right, let's go to wired and attach content toolbox here. Do we still have our log points? Yes, we do. So I scroll down, and now let's click on a link. And it's connected to 80392, which is this content process. So click on link. So in here, what happened was we attempted to serialize about new tab. Right, because it's serializing the history as well, like the first entry in the history. And then in the case of the wired story, the pres state scroll is, like that scroll value is where the pres state information is where the scroll value is gotten from. And presumably, if I click back, yeah, so pres state scroll seems to be the important part here. Not like the scroll position that was set on the SH entry directly here, but this pres state thing. So that's where I'm going to try and focus my attention. Okay, this is a thing that you get in RR because of sandboxing, and the way you deal with this signal that keeps coming up is handle sig sys no stop no print, and you continue. That's directly from the RR manual. Okay, so what happened? This layout history state thing is what's, I think, the important part here. What interacts with it? Let's try and figure that out while we wait for RR to kind of help us be in God mode. So let's ask Search Fox who touches layout history state. So here's the implementation, here's the interface. Session history obviously touches it. And then there's like a bunch of native code, IPDL. Interestingly, it goes over IPDL as well. This is probably for the transitional work to running session history in the parent process that's not yet done. Synchronize layout history state. I don't know what that's all about. What's that? Init layout history state. So SH entry is what owns the layout history state. Then there's like a shared base class between NSH entry and I think NSH legacy entry. I think there's like a couple of different implementations while we're in this transitional state. I think there's a legacy one in here. Yeah, legacy NSH, legacy SH entry and layout history state. That's interesting. Okay, where are we? Okay, so we've hit our math.sign function. That's really interesting. So if I say like call dump JS stack, look, I can see exactly where we are. We are at line 242, which is as expected. It should be toolkit modules. Actually, yeah, sorry, normally I don't care where we are in the C++ code, I want to know where we are in the session store code. And it's exactly where we said we would be, session history. Math.sign, we're right here. So we're about to get the scroll position. And then we're also about to get the layout history state. So we can actually hook the attempt to get at the layout history state by saying break. Well, we should be able to say like break NSH entry, NSH legacy entry, I guess. What would it be? I think it's this, NSH entry get layout history state. Are there any other implementations that get layout history state? Entry child, SH entry. I think it's just the one. I'll do SH entry child as well. So set a breakpoint here and break on, I don't think we're gonna hit this one because this is the like, the sort of fission related one that I don't think is actually done yet, but just in case, set a breakpoint there as well. And now let's see who we hit. Yeah, so we hit the first one. NSSH hit entry, get layout history state. So this is a great first step. We now have the NSSH entry for about new tab, presumably. Let's actually double check that. We can look at the, what was it used before? The URI. We can get at the URI of the SH entry. We can double check and make sure. So let's just get at that. Pardon me. Let's see here. URI. MURI is a protected member of the SH entry. So let's take a look here. PMURI. It's a raw pointer. This is some kind of NSI URI though, right? Yeah, tell us what kind. It's a simple URI apparently, says the V table. So we're gonna cast this to a Mozilla Net NS simple URI. Oh no, someone's saying, hey Mike, yeah? What's up, Max Jowett? What's up? What's up? What's up? Okay, here's the MURI information that we're looking at. And it does look like it's an about page, it's about home. That's fine. I was expecting about new tab, but it's about home, which is the same thing. It was the first tab that showed up. That's fine. It's the exact same thing under the hood. They both direct to the same underlying page. So good, we're looking at the right history entry. So I'm actually gonna start taking notes here. I'm gonna say RR session debugging why layout history state doesn't have scroll position. Is the music too loud? Let me know if I should, let me know if that's too loud. I actually think that might be a little too loud. I'm gonna bring it down. Okay. Okay, so we're making good progress here. We've got our SH entry. So let's record this. This is the operative NSSH entry, the one that we care about. Let's write that down. Because this memory address is something we can use again and again every time we run this particular trace. Because I might quit, I might decide to come back, I might package it up and like save it to disk somewhere and want to come back. So, you know, it's handy to have that sort of thing written down. Now I want to know about its layout history state. So its layout history state, I presume that's a member on SH entry. Layout. Huh. M layout history state. There's like a shared base class, I guess. Yeah. M shared. So there's like a separate thing called an M shared, which is the shared state. We share the state in here with other SH entries which correspond to the same document. Oh, okay. Never mind. And that has layout history state. Okay. So M shared. Is that what it is? Yeah, M shared. DOM SH entry shared parent state. Okay, so cast that, and then we want to point at the layout history state. Forward there, yeah, okay. Sometimes I forget and I get scared about keyboard shortcuts, even the simple ones. It's M layout history state. So there it is. So let's write that down. Well, actually, let's cast it first. So a layout history state is of type NSI layout history state. So we have to cast that. Well, actually, I'm going to cast it to its base class, or like the implementation class. So presumably there's something called NS layout history state. That's generally the pattern. Yeah, I think we already established that before. So I'm going to cast this not to the interface, but to the base implementation. NS layout history state. You gonna let me do that? Yeah, great. So this is an important piece of information. Is it still too loud, Smurfdy? Or is it better now? Max Jowett says, I decided I should do a COVID-19 reformat. Taking a break from setting up all my configs. Yeah, it's a great time to take a break. You know, do whatever you need to do. Now is the time to just sort of like take it easy. Try not to stress out. Okay, so we've got our layout history state here. And what do we do whenever we have one of those things? There's like a serializable pres state. We get a pres state on it. So how does that work? Get pres state. There's like a state thing, get state, and then you pass in a key. The key in this case will be a string. Get keys, layout state, get keys. Get keys is implemented on here as well. So there's like an M states collection, a hash table of states. Oh, this is going to be a pain. What might actually be useful is if I can figure out what we typically what we typically use. So pres state, what's the state key? Log. Serial pres state, state key, state key. Okay. Whoa, that's weird. It's a weird state key. 0 greater than HTML greater than 1. Okay, so and then we get one. We're going to get this I guess that's the most important part, is that we're going to attempt to get this pres state. So maybe that's where we should break next. What? Break NS layout history state. Get pres state. And did I accidentally set a breakpoint? Yeah, disable for. Did not mean to do that. So continue. Continue. That's interesting. It doesn't look like we actually get there. I'm gonna stop. I would have expected us to reach it by now. So I'm gonna reverse continue. Go back to where we were, to JS math sign, or wherever it was that we were. I guess it was when we were getting the SH entry. So I guess we never reach here because maybe there are no states. That's maybe why there are no states. Layout history has states. Maybe it does. We know it exists, but maybe it doesn't have any states, and that's why we don't persist any. And maybe that's a problem. Let's see if we can confirm that. I'm gonna close. Whoops! I didn't mean to shut down the whole thing, but it's okay. Let's relaunch the browser. And let's run the browser content toolbox on about home. Okay, so we've got all our fun things here. Let's see if we have states. Layout history state. Has states. This is gonna fail if layout history state is false, but I don't think it will, like if it's falsy or it doesn't exist, but in our case I'm reasonably sure it does exist. Scroll, click. Oh no, it is null. That's interesting. The layout history state was null. Why would the layout history state be null? That was an interesting result, because it doesn't exactly match my understanding of what's going on inside of RR. Child side updates layout history state when page is being unloaded or moved to BF cache. Move to parent? Layout history state. So who creates this? Set layout history state. Calls that set layout history state happens inside doc shell. When we prepare for new content, we clear it out. When we capture the history state, we'll do it here. If there's not already history state. That's when we set layout history state. Interesting. Okay, let's go back to RR for a second. Let's watch this location and see who writes. Who writes to that? Who set that before? And then I'm reverse continuing. So hopefully I can see how the layout history state was constructed for the RR case. So while we wait for that to sort of figure itself out, interestingly, or maybe perhaps unsurprisingly, or maybe surprisingly, going backwards, I find, like reverse continuing, tends to be slower, especially if you have memory, like watch points like this. So we might have to wait a little while. In the meantime, we can do some more visual inspection, maybe some printf debugging over here. So layout history does not have states. So why not? When we call pres shell capture history state, who calls that? That happens whenever we hide the document viewer. It happens whenever we persist layout history state, when we construct doc element frame. Interesting. So you would think that if these are all the things that could cause the layout history state to be created, that it should have been created. I'm interested in knowing which one actually created it over here. Hopefully RR tells us soon. Let's look at this function, persist layout history state. is that? When we destroy, we embed, or we restore from history. So whenever we're destroying the doc shell, we want to save the state of the current document before destroying the window. This is needed to capture the state of a frame set when the new document causes the frame set to be destroyed. This is where I expect the layout history state definitely to have been, like, basically whenever we navigate away, when we're in the process of destroying the old doc shell, that's whenever we should be, like, persisting. And it looks like that's set up. While we're waiting for that, you know what I'm gonna do? Run debug. I think my local build, I've got a local debug build that's pretty much ready on Mac OS. Why is it taking so long to go backwards? I wonder if it would help if I disabled some of my breakpoints as well. It's less things for it to check. Like if I disable one, can I do multiples? Yeah, disable 3, 4, 5. So I just have the one watch point. Okay, let's keep going. That might speed things up a little bit. Fewer things for it to check. Oh yeah, what happened to the music? I'm gonna put the, I'm just gonna loop this album. Give me information, RR. Grrr. Okay, so I've got a debug build here. Let's, on my local machine, while we wait for RR, while we wait for RR, I always sound like a pirate. Let us, oh, actually, no, I don't want to do that. I want to just do a normal mock run. I want to attach to a pre-existing content process. Because I don't want to attach to the parent process, I want to attach to the privileged about content process. And pump up the font so you can see what I'm doing. Okay, and we're going to be running inside of content process. What was that? No, no, go home, go home. Thank you. That's process 84747. Do 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 do. 84747. RR still RRing. What's going on here? I wonder if maybe instead of having I use the watch point, we could make it faster if I hook this function instead. If I like break on it. Disable 6. Like that's assuming that that's the function that causes the layout history state to be created, which it might not be. Okay, so here's our, we've got ourselves attached to the content process. And that's why this page is not, it's like checkerboarding. It's because we've got the content process all locked up. What I'm going to do is I'm going to say break on doc shell persist layout history state. Where's the terminal? Break there. Where else would I want to break? Maybe actually we want to break set layout history state. Maybe that's where I want to break. Set layout history state. Yeah. So we continue, and now I'm going to navigate. So I scroll, and I click on old Carl Sagan here. Alright, so we've hit our breakpoint in the privileged about content process. What's our back scroll look like? Or our backtrace? I presume this is the destroy thing. Oh, this isn't looking good. RR, pull it together. Okay, so yeah, we're on destroying the doc shell as we navigate away. We decide to persist the layout history state. So let's step through this a little bit. Do we have an MOSHE? Yes. Do we? Is scroll restoration manual? Shouldn't be. Is manual. This should be false. Good. Let's see if we have a pres shell. We do have a pres shell. Now we're going to capture history state. Good. Step, 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 step. Step into step, all this stuff. Step into capture history state. Step into capture history state. All this abstraction. Thank you. Okay, so here we go. Null state pointer. Check to see if there's a doc shell for the pres context. There is. There's no history state. Oh, there is a history state. There is a history state, so one does exist. One does exist. Huh. So then how come it didn't exist when we were checking before? Maybe it got created after we started looking for it. Maybe we have an ordering problem here. Okay. Okay. Thinking. Yeah. Session history. If layout history state and not layout history state that has states, dump. There are no layout history states. And then what do I want to do? I want to put a breakpoint at sh entry shared set layout history state. History. Layout. Okay, maybe it's sh entry then. sh entry, that's EP. Layout history state. Set layout history state. Setting a layout history state. It's just see what order this comes in. Step by step, day by day. Hey, RR. We're back in RR land. So that's good. We might be able to answer our question here first. We are in persist layout history state, but not at the destruction point. We're persisting layout history state on the dock shell whenever we're first creating the dock shell, looks like, when we embed. Okay. And there's no wait, what line am I on right now? I'm on line 11210. Because there was no MOSHE, which doesn't surprise me because it's so early at this point in the life cycle of a dock shell, that persisting fails. Okay. Break. Hang on. Break. Breakpoint there. Set layout history state. And then we're going to re-enable our JS math sign function. We're going to go forward now. Where are we? We're in set layout history state, so we hit that first whenever we capture history state when we are constructing the document element frame. Okay, that's good. And what do we have for, I think I screwed things up by changing the visualization briefly. Persist layout history state. Okay, next. PA state. Is that the one we were setting before? We wrote down? Yeah, that's the one we were setting before. Great. There's this, it's this collection of things. You can maybe add a new pres state, you can add a state. I don't know what the difference between these two are, but they both ultimately write to the states object. Pres state, make unique pres state. Okay, I'm gonna set breakpoints on add new pres state and add state if this equals this memory address. So only if we're talking about layout history state that we care about here. So then we hit math sign. So we set our, we never added the scroll position. We never added the scroll position by the time we started looking for. That's interesting. So whose job is it to call add state to this add NS layout history state thing? We created one, at least in the RR case. I worry a little bit about the non-RR case because we saw it was null before. So let's hope it's not non-deterministic. That'd be crazy. Oh, there's a little bit of coffee left. Okay, we'll ignore all of the log messages up until now. state. Guess that's not super useful logging, is it? No, layout history states. What am I trying to do here? Instead of setting the layout history state, it's more about the writing the presentation state. So let me actually, what do I want to do? So don't need any changes, just run the debug build again. That's ready. Do an experiment. Because in this, I want to see when we normally write the pres shell scroll position stuff. Because we didn't, in the RR case, we didn't do it. We just didn't do it. So I need to see what the correct case is. So here's a content process, 86381. Let's attach to that. 86381. Say add new pres state. We're gonna hook that. We're also gonna break on add state. And we're gonna scroll. So it doesn't do it every time we scroll, but I guess, oh, hang on. Yeah, it's painting, okay. Now if I navigate, so let's click on a link. Please don't open a new window. No! Stop it. I want you to navigate from here. So I need like a link. No, stop opening a new tab. There we go. Okay, so we put some state information. What's the state key? It's that weird format again. Some kind of like, especially, like it's almost like a little language to describe, I guess, structure or something. And then we're persisting a state. What's our what's our trace? We do it when we say, well, this is for the like the new page whenever we embed. State 4. I'm so confused. Okay, content viewer to embed. We persist the layout history state of the doc shell. Save the layout history of the previous documents. This is for the previous document. That makes sense. So we're capturing the original frame state. And we have some state. So let's take a look at the state that we have. we were in add state, and a state is a pres state. What is a pres state? Pres state has scroll data. Has scroll state. Right? Scroll state. Let's take a look at that scroll state. A state, scroll state. Yeah. Now that seems really, really high, but that's because it's like converted to like a different unit. But that looks like we had scrolled by the Y amount. That's good. So why don't we... Why aren't we doing that when we process flip? Why don't we do that when we process flip? And is there a way we can where we can make it happen? I have a feeling we're not doing it when we process flip because the dock shell is not actually navigating. We're like, it's almost like a crash where we like just throw away the dock shell. So we never persist. That's my hypothesis. I wonder if we make the persist happen before we do the process flip. Let me write this down. Theory. Because a process flip causes us to throw away the old dock shell rather than navigating it, it doesn't kick off the persistence, layout persistence code, so it never saves the pres state to the layout history state of the NSSH entry. That's the theory. Okay. That's pretty good progress, actually. I want to see if I can confirm that before we close out here, especially since it was kind of a crashy stream. Although, it hasn't crashed ever since I updated OBS. Let this be a lesson. Update your software. Although, I don't know why it only started crashing now. Who knows what changed elsewhere in the ecosystem of things. History state. Is there a way like I can cause that persistence to occur? It happens here because of capture frame state, persist layout history state. Is this function something that can be called from script? No. No, it does not. What's this? Synchronize layout history state. What does that do? So the stuff on IDL is like, that describes things that are exposed to the JavaScript layer. I can get state. I can add one from script. Can't do these ones because they're no script. But I could, in theory, say add new pres state. That's interesting. Does any JavaScript ever do this? Yeah, in session history, when I deserialize. So it was like, we're kind of set up to do this already. It's just that by the time we do this session history serializing of an entry, we never persisted the state. And so is there a way I can cause that persistence to occur when we do a transplant? Let me think here. When we do a frame swap, like a navigate and restore, or remoteness flip, whatever you want to call it. Navigate and restore. Async, navigate, and restore. And internal logic, we flush the content. So at this point, we haven't actually done we're like just trying to get the state. We flush. See, it's right around here that we want to have had the layout history state written. Or even earlier. Store. Navigate and it's like remoteness is the key word here. This change recently? Because I feel like there was a function that I think this changed really recently, like yesterday. I made change process within the document load listener. So I think some session stuff got removed that I was expecting. It got moved to tab browser. Perform process switch now exists in tab browser.js. It's no longer inside of session store. And all of this stuff went away. And now all of a sudden document load listener's job is maybe trigger process switch. There's a bunch of native code. Perform process switch, so that's what calls navigate and restore. And then perform process switch is called here. Is this all in the parent? I think this is all in the parent too. The document load listener serialize redirect. What I think I want to do is call where's it? I want to call persist layout history state at the point where the redirect, like just before we do a process flip. That's what I want to do. So I'm gonna hack something together. And we're gonna see whether or not it helps. I don't know if this is a good idea time-wise, but just gonna hack together a thing just to test. Oh, first I want to see what synchronized layout history state does, because that might already do what I need to do. Synchronized layout history state. What does it do? No op on purpose. NSI.shentry.idl. Can be used to synchronize late history state object to the parent process in case session history lives there. Within process session history, this method is a no-op. Okay. Who calls this? Removed from dog show. Doc show. Okay. Destroy. What if we modify this function just for now, just to test, instead of doing a no-op? It do whatever persist layout history state was doing. Which was what? History state. I think we already figured this out, where would the add state occurs inside of capture history state. Yeah. Here. So instead of being a no-op, do I have access to the test shell here? No, not directly. Not necessarily. Also, I want this to be sort of like a workaround. This is all going to get fixed whenever the fission people are done. So I wonder if... tab state flusher. I'm going to say flush. Process was that. I wonder if we could hook that somehow. What is this? What is this sent? Browser changed process. That's after though. That's after the fact. We need something from before. think I need to talk to the Dom team. Oh, Just Cuz asks, hey, how's it going, Mike? I'm good. How you doing, Just Cuz? I think I'm going to stop here. Brain's melting a little bit. Need to get more lunch in me. Also, I think I learned something today. Like, I'm reasonably certain that this theory, the evidence that we've gathered from LLDB and RR seems to support this theory. That on process flipping, we skip the step, because we don't navigate the doc shell. We skip the step of persisting its state. Because we skip destroying the doc shell? Because the destroy happens after, probably. We do the flip. We probably tear down the pres shell. That's what happens. The tab goes away, like the content goes away, we navigate, and then we try and scoop up that information. Locked up in the parent process. Okay. I'm gonna run with this theory. I think I want to prove it out more. I'm still learning about this area, but I'm gonna run it by some people on the Dom team who knows about session history. Sorry, I'm just looking at the I'm looking at my monitor right now, and I was doing this. There's a little bit of delay. I saw myself doing this. It looks like I'm like having a really bad time, but this is great. Like, I feel like I've made a kind of a breakthrough today. But now I just need to confirm it. Just Cuz asks, have I ever seen the documentary Code Rush? I was curious how much code from that era still runs our favorite browser. Some of it, not much. Though that's like 20 some odd years ago. And so a lot of that code's gone, but a lot of the sort of the atoms, like a lot of the primitives that existed back in those days still exist. Like NSCOM PTR is that's the smart pointer that we use for XPCOM, our component object model system. And you can see in the code that flies by, I think in that documentary, a couple of NSCOM pointers. And NS in this case that stands for Netscape. NSCOM pointer. If you've ever, like, when we were looking at a bunch of classes today, like NS layout history state, that stands for Netscape, and that's like sort of like old school namespacing. Whenever we didn't have like C++ namespacing, you would prefix your classes with some kind of unique identifier, which is really sort of confusing, especially whenever you find that some people use the same prefix, like the next step people in Objective-C. That's why, like, whenever you're writing Objective-C code for Mac OS, a lot of those things start with NS as well, which is very confusing. Thankfully, however, we lowercase our NS and they uppercase it, so there's a little bit of a difference. But so to answer your question, Just Cuz, not a lot, but some. There's still some, and it's like the small, older things, and like a lot of those things have been updated over time. Like, we have this component within Firefox called NSPR that stands for Netscape Portable Runtime, and it is like the abstraction layer that allows us to be platform agnostic for things like threading, like lower level systems-y things, and that all existed, I think, back in the day, whenever Code Rush was being done. That's leftover code from the Netscape era, the Netscape Portable Runtime. You can use NSPR inside other applications as well. It's like a separate product, I'm pretty sure. You can like build it separately. It's pretty wild. All right, I think I'm going to stop the stream here. Thank you so much for watching The Joy of Coding episode 213. I apologize about the sort of unstable stream today. We crashed a couple of times. I believe, fingers crossed, the OBS patch that I applied halfway through the stream is going to work from here on forward. I'll just know to check for updates maybe before doing another stream, and so that won't happen again. I don't know if this is going to delay me posting it to YouTube. I got to find where the recording is, and so this might be a bit of a problem. We'll see. But again, thank you so much for watching. Have yourselves a great week. If you can, smash this, rate this episode link inside the agenda, and let me know what you thought of the episode. I read everything that comes in, and it helps me shape the stream and make it better for you. If you're watching this on YouTube, please like, share, subscribe, all those fancy words that people use. If you're watching this on Twitch, you know, give yourself a fist bump. Twitch, eh? All right, I'm going to cap it here. Thank you again for watching The Joy of Coding, and I will see you next week with episode 314. And here we close out. Take care. Bye-bye.
The joy of coding.
See ya.